Broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, this is Naveen from littleBits. I'm talking to you today from New York City, where we are currently getting our first nor'easter and our first snowfall of the season. So thank you for all that have joined us here today. We're going to be talking today about teaching an introductory unit on coding using the littleBits code kit. A little bit about my background. I work on the education team at littleBits, leading community programming. I started off actually as a classroom teacher. However, I taught middle school humanities in New York City public schools for 6 years before moving into nonprofit education, and now have been really excited and privileged to be at littleBits for just over a year now. And I'll talk a little bit more about how my experience as a teacher has really made me more and more passionate about littleBits, and littleBits has given me confidence in my teaching ability. So to go over our agenda, a couple of things. So it'd be really great to know where you all are from, what you teach, what your background is, what your interests are, what you're hoping to get out of this. So you can use the questions function if the chat function is not available to you in your control bar. Use the questions function both to introduce yourself, not only to me and to my colleague Max, who is in the background to answer any sales or product related questions, but also to introduce yourselves to one another, because I know that we have people from as far away as Denmark already on the call that have said hello. So we really appreciate you joining from far and wide. So feel free to use that questions poll, introduce yourself, tell us where you're from, what you do, why you're here. And then as I'm presenting, feel free to put in your questions. If it is product or sales related, Max, my colleague who is on the line, he will reply to you directly or reply to the group. If it's content related, feel free to put them in the questions section, and then I'm going to address as many as I can at the end of the webinar when we'll have a question and answer section. If you are having okay, good. Everyone looks like they're introducing themselves. So a little bit of the agenda today. After I tell you a little bit more about my background and why I'm so excited to be talking about the code kit, we're going to move from looking at what the code kit is. Some of you might have joined us on our first webinar in this series, which was Teach Coding in One Lesson, where we focused on a particular Hello World lesson. I'll be talking about how you can catch that replay later on. I will review an introduction to the code kit and materials, but we'll be focusing much more in this webinar on all of the content and resources that come with the code kit, both in the app and that are available online to you to teach a full unit in coding to your students. I have some cool projects from the classroom recorded by teachers of their students using code kit that I'm really excited to share with you. And then at the end, we'll have questions and answers. So thank you again all for being here. So for those, just really quickly, for those of you who are not familiar with littleBits, littleBits is a modular platform of electronic building blocks that snap together using magnets. And they allow students to invent anything. And we're really focused on having students become active inventors using technology instead of just being passive consumers of it every day in their lives. And so this is what it looks like, or a piece of how the platform works. So these are some bits from our code kit. As you can see, everything is color coded. The bits snap together where you see the color bit snaps. There's a magnet. They snap together seamlessly. The blue is power. Pink bits are inputs. They help control something. Green bits, like the one you see on the screen, are outputs. They do something, whether they make it show an image, make a sound, light up, etc. and orange bits are wire or logic. And we're going to talk about our very special orange bit today called the code bit. So with this modular platform, there's numerous different kinds of inputs and outputs and wires and logic that students can use to really invent and imagine and create in limitless ways. So let's look specifically at the code kit, because we at littleBits we have different kits, and the one we're looking at today is the one that really we recommend was designed for the classroom to introduce students to coding. So when you look at the code kit, this is what basically comes with it. In the kit, you'll get a kit supports up to 3 students. It's made so that students work together and collaborate on their work, both on building the physical invention and then in exploring block coding. There are educator materials and student-facing materials inside the box. And then what's really amazing and robust, I think, and just easy to plug and play is everything that you'll see that is on the app. And so most of the learning, most of the time, students are going to be using the app, but you have supporting materials in the background to help facilitate their use of the app as they play with the bits. So here's how it works. With the code kit, students first will run the app. The app doesn't need to be on the internet. It needs to be downloaded, so your computer needs to be connected to the internet to download it. But once it's downloaded, it can be open and run when you're offline, which is really good if you have laptops or Chromebooks in the classroom, and having all of them on internet connection at once can sometimes make it really slow. So students will start by watching a video tutorial where they'll build an invention or a small circuit with littleBits. And then they'll use block coding, drag and drop block coding, to send code to their invention to create games that they'll then remix. And in this process, they'll learn about how the bits relate to one another, how the code relates to the bits, and how when they change the code, it changes the function, the actions that they see being performed by their bits. And this is all made possible by the code bit. So the code bit allows, it really levels up littleBits. It allows for the connection between the block coding that your students do on the canvas to be sent to the physical bits. And so I think that the code bit, I like to say that it helps make coding come to life, or like coding become 3D, or coding become tangible, because students are going to see immediately the results of their code, and as they manipulate their code, how that affects the actual bits in real life in their hands, and they'll see the sounds, the lights. It's a very tangible experience that really helps beginning coders understand what code is and how manipulating code really changes what it is you want to do towards your purpose or goal. And so this is done via Bluetooth. So the code bit is something that will be included in each of the students' inventions. And then there's a toggle that goes into your computer so that the code bit can wirelessly send the information your students code to the invention. And then there's the app. And so the app is what I've been talking about. The app is actually what really I think is the best part of this product as an educator. So I'll stop for a moment to talk about why. I was a humanities teacher. So my undergrad was in English literature, and then I went to grad school for teaching English. So very much into literacy, books, etc. Really no math, science, engineering, tech background. And so with the importance and the growing importance and sort of the agreement, I think that STEM and STEAM learning not only needs to be part of every student's education, but needs to be taught across grades and also across disciplines, so that we need to have STEM and STEAM incorporated not just in our math and science and technology classes, but in our English and social studies and arts classes. The challenge there is that sometimes teachers in those areas feel that they don't have the background to incorporate STEM or STEAM into their lessons. I would have been one of those teachers. Perfectly comfortable teaching writing strategies, reading strategies, analysis. But if I was asked by my administrator to incorporate coding into a literacy unit or a social studies unit, I probably would be very hesitant to do so. Probably thinking, oh, well, I don't know coding. I'm not an engineer. I'm not a scientist. This is not my background. What I love about the Code Kit and what really excites me so much about this product is that it's all there for you. So the student-facing materials are there. The lesson plans are there. There's student-facing video tutorials. There are teacher-facing videos. It's really plug and play, and it's really developed so that I can sit at home and go through it and actually be introduced to coding myself as an adult, and then easily feel comfortable bringing it into the classroom. And the other thing that I think is, a teaching style, but I think an important one, is that you can, and I think it's really powerful when you learn alongside your students and show your students that you are also constantly learning. And learning isn't just a process that ends when you graduate, but that we constantly push ourselves to learn new things, and that making mistakes is okay. And I think it really humanizes the teacher that that it's okay not to know everything, but you can learn together and make mistakes together. And I think it gives students more confidence because they then have opportunities to teach you, which I'm sure as educators you often know, students often turn around and are the ones teaching you before you know it. So in addition to the app, there is an educator portal. You'll see the URL highlighted at the bottom of this screen. And this is it's sort of, we call it the hub for CodeKit. It's got everything you could need related to CodeKit and teaching a CodeKit unit in one. It has the place where you can download the app. If you look at the right bottom of the screen, it has a link to teacher tools, which are going to include lesson plans, standards, alignment, slide decks that you can use directly with your classroom. And then there are handouts, and we're going to be going through these materials in more detail throughout the webinar. There are also videos that are designed directly for the teacher. And you see they're all short 2 to 3 minute videos, but they really help onboard you. And these are real teachers and ones by our CEO talking about the kit, and you get to see it in practice. So this portal, the great thing about it is if you don't have the Code Kit, but you're interested in it and you want to see just how robust these resources are that I'm raving about, you can go to this website right now, to our Code Kit welcome portal, and you can watch the videos, you can look at the lesson plans, you can download the app and watch even the videos that your students would watch. You can even play with the block coding interface. The only thing you won't be able to do unless you have the code bit is send code to your littleBits inventions. But I highly recommend that you take a look at the educator portal for CodeKit and really get to see for yourself how much is there, how much has been done for you to make it as easy as possible for you to teach coding and integrate it into your classroom. And I personally appreciate that this amount of resource is part of this product, because I know from experience and from working with teachers, after I left the classroom, that teaching is, one of the hardest jobs in the world. I really, truly believe it is. And teachers have so many things on their plate. And I think not everyone, or people outside of education don't necessarily realize that. And so giving teachers tools that they can easily bring into the classroom in meaningful ways, I think is one of the greatest gifts, really, that you can give a teacher in terms of when you're giving them tools and content that can, of course, be modified by the teacher to make it their own. If you want to learn more about the Code Kit, one of the videos that I recommend watching, which is both on the Code Kit Educator portal, which I just talked about, and also on YouTube, is this Meet Your Kit video. You could just search for it on YouTube as well. And this is one of our teachers in New York. He unboxes the kit and really walks you through each piece. So I'm not going to show this to you now, but please do, watch it on YouTube or visit our Code Kit site and take a look. So again, when we're diving more deeply into the resources, so let's look at the teacher tools. Again, the URL is at the top right corner. So if you want to take a look at this on your own and actually click through everything, you can do that now or later as well. So you have things like an implementation checklist, a curriculum guide, which is going to give you everything from standards alignment to different ways to structure your unit to best fit your students and the time you have and the ability level of your students. And then there's a curricular crosswalk that really details alignment with CSTA and NGSS standards. So from my point of view as a classroom educator, you've got every handout, you've got every PowerPoint deck, you've got every student worksheet or an assessment tool that you'll need already created for you. And what's great is that the majority of them are in Google Doc format so that you can actually make a copy and edit them to be your own. So you can personalize them, you can adjust them, you can modify them to your students' needs, but you have a really solid, ready to use piece of material that you can then make your own or use as it is. So looking at the curriculum, so we're talking today specifically about using the resources in the Code Kit to teach an introductory unit. So again, we had our first webinar on how do you introduce coding to your students in one lesson, and we talked about the Hello World lesson. So I'm not going to spend as much time today talking about Hello World, but I do, if you are interested in hearing about that lesson in more detail, I will give information on where you can watch the replay of our first webinar. But this is the scope and sequence that we recommend, and this is in the curriculum guide that you can again access online for teaching an introductory unit. And this will take you, depending on your students, grade level, the amount of time you have with them each week, and their sort of ability level at the start. This can take you anywhere from 3 to 4 weeks, give or take. So you would start with the Teach the Hello World lesson, and then you would go through the coding. There are 5 coding tutorial lessons, which are really nice. These are before they start inventing with littleBits, really teaching them through direct video tutorials and sending code to their bits about things like loops, logic, variables. And so the Hello World lesson would be about your first lesson, and that's to give students a real experience right away with coding. And then they sort of step back and learn about the essentials of coding. They then do create 4 different inventions or 4 different games that they then remix. So depending on, again, your class session and length of time, you could either spend 1 or 2 lessons per invention. And then this unit would end with a coding challenge, which is an open-ended prompt. The coding challenge is called Change the World Arcade. And so students will actually have the freedom to use all they've learned about how bits work together and block coding and beyond, and engage in project-based learning to identify something in their community that they care about, that they want to make better, or a problem they'd like to solve. And then prototype something that would address that via a game. So here is where you can access the introductory webinar on Hello World, where my colleague Erin and I talked more about this tradition. So this first activity, and again, students would open the app, they'd see click Hello World right away. They'd watch a short tutorial about the history of Hello World. Which is basically, it's just we're bringing them right away into this tradition that coders traditionally have programmed, have had their first program be Hello World. And so it's sort of this tradition in programming that Hello World is your first code script. And so we have students do that with our drag and drop block coding, but they actually send the message hello world to the LED matrix, which you see with the heart on it right now, and see it scroll across the screen. So they're getting a little bit of a history lesson, and they're getting, we're putting them under the wing, we're grouping them with coders, and making them official coders from the start. And then I mentioned they go into code tutorials. So after your first lesson, where they will learn about hello world and have a really immediate experience with coding, then we have them step back a little bit to learn about some coding basics. I really personally like this, especially for beginning coders or at any level, because there are short videos with 2 to 3 action prompts after, that teach students about inputs and outputs, about loops, logic, variables, and functions. And so students watch a short video, and then using their bits, they put together not full inventions, but sort of go through some smaller activities to really practice and understand these basic coding concepts. So this is a great way to build their background knowledge in coding and what they're doing before they move on to really inventing in the coding canvas. What I really like about the code tutorials is the way the videos take students from where they are and experiences they already have into what are little bits and how do they work, and into coding. And so they start with the concepts in real life. And I really like this because it takes something, coding concepts can seem very nebulous, they can seem very vague, they can seem abstract to certain students, particularly younger students. But when you start with something like their senses, and talk about how your senses are actually inputs, right, received by your brain, and then your brain does something with them, and your output might be a smile, might be a laugh, might be a cough, etc. So this taking like the real world 5 senses and relating it to inputs and outputs is really like a very tangible, clear, easy way for students to understand what we mean when we're talking about inputs and outputs, and what bits do and what code does. And then after that, after you talk about the senses, then you tie it directly to the bits. So they realize that your senses, so things that you see and smell and touch and taste, those are the inputs. And then they learn, okay, well, pink bits are inputs. Your brain is equivalent in the bit world to the code bit, because that is what is going to process and do something with that information that was input. And then green bits are an output, so they're going to display that information, whether visually or in a sound or with movement, just like we do as humans with our senses. And then finally, the same analogy is used to talk about code. So they learn that there are code blocks that are inputs, and there are code blocks that are outputs, and that there are a variety of different types of code blocks that are sent through the code bit, which is sort of the brain of the bits right here, between the code and the physical bits, which is going to create the output that you've coded. So all this is done within the coding tutorials. And so the tutorials are great because they're small and they're direct and they're digestible bites of information. And we suggest that you spend a day or 2, depending on your students, on each coding concept. And I just want to show you a short video taken by one of our teachers here, where you'll see the students playing with the bits and learning about inputs and sort of understanding about inputs through play and through trial and error. So I'm going to play this for you so you can sort of see students actually learning by playing, by discovering, and by seeing what happens in real life instead of just hearing about it or reading about it.
You can squeeze it between your fingers. Now, what if you switch that over here, and instead of a slider, you have to squeeze different pressure? Try it.
Oh, it does! So it changes no matter what. Oh, that's so cool!
Make sure you let Robert get a chance to try.
So that's just a little, it might look very familiar to you, a little like, in action, students playing and learning from the very beginning with the bits. And the great thing about them being modular is just like the code blocks are modular, and just like coding is really a modular system, so are the bits. And so as they're learning about how the bits work and relate to one another, it reinforces their learning of how the different code blocks work and relate to one another. Great. And so after students finish going through the code tutorials and they've learned about the basics of the different coding blocks that they'll work with, and they've learned about the basics of bits and how they work with one another in their color-coded system, they get to immediately apply the coding basics they've learned that are going to be incorporated into these invention lessons where they can really dive deeper and bring their coding to life. So there are 4 invention lessons. The one you're looking at right now, Ultimate Shootout, they're all around games, and this one has students invent a game where they're sort of doing like a mini tabletop soccer, and they can change what happens on the LED matrix. It can be a scorekeeper, it can play something, it can show different images, and that's all manipulated by the block coding in the canvas. So the student would, for the Ultimate Shootout, would click on the invention, and then they'd watch a short video which would take them through the build. So first they'd build with the littleBits. And when they were done, it would prompt them to let them know, now you're going to work with the code. And as soon as the video stops, they're taken into the coding interface, and the block code for that invention, the basic block code, is already there. So all they have to do is upload it and see it. And so you might be wondering why we put the code there for them. It's actually so that they can, instead of just seeing this code or struggling first with trying to figure out, how to put together the code to make it do, what they want it to do, they can upload it directly to the physical bit invention that they have built, and they can see in real life, see and hear the code come to life. And so then they can look from the bits to this code and really understand what each block is doing, because they're seeing immediately what happens when this code is sent to their bits in real life. So just this immediate learning, this tangible, this like in the moment, present learning that students get this experience with. And after they do that, and they also have immediate success, right? So their code works the first time they upload it. So that's also just really giving them this motivation and this confidence as they're being introduced to coding. And then after that, if you see on the right-hand side, there's a smaller screen, and it says level up your game. So then there are, with each invention, there are remix prompts that challenge students in an open-ended way, but with just a little bit of guidance to do something like, change what's displayed on the LED matrix, or change the amount of time, the game is running. And so they figure out how to do that by manipulating the code blocks on the canvas, and they also have a menu of different code blocks that are categorized on this left-hand side that they can add to their code on the canvas. So they build using a video. The code is already there on the canvas. They upload and play and learn and just are able to see what the code does, and then they remix. And when they're remixing, they're really applying and they're showing their understanding of what the different blocks do. And so I want to show you a couple of students with inventions. And so here are some students playing with one of the inventions, which is the rock star guitar. So I'll just let you see for yourselves right here. It was really cool because they kind of did like a band.
And Isaac. And Caitlin. And now all three.
So you'll notice that, I don't know if you noticed, but they had different things displayed on their LED matrix. You can see that the students each personalized and designed their guitar to be their own, to be unique, and that's where littleBits brings the A in, taking it from STEM to STEAM by incorporating the arts, both in the coding and in the bits with the LED matrix, but also by incorporating physical craft, so that they're taking their bit inventions and they're making them look like guitars. And this is pulling in a whole new group of students who might not have been interested in sort of straight coding or straight building with electronics, but get interested when they get to make it look, design it to look like something they want to create or craft. I'll play you another little example of students playing with their CodeKit inventions.
I saw the G.
Don't take it over there because then it pulls the computer.
Hold on, you're blocking it with your hand. There it is. Okay, now change. That looks cool.
So students can also do things like changing the notes. Really, there's lots of different ways they can remix, and that remix is a way for students to level up and for you as a teacher to push your students further, and also adjust for having students in a variety of levels within the same classroom. And then remixing, I want to show you two examples of remixing that are super cool. The first one is a remix of that Ultimate Shootout game, but they turned it into a different game, and I'll let it speak. I'll let them speak for themselves.
Go ahead. Go ahead.
All right, is it starting?
Yeah, the video is starting.
Then you can show us the video after.
You're so good.
So there you see some ping pong game invented by students. And here is a really cool mix of the Ultimate Shootout game as well. This one you don't hear the students, but if you watch the narrative, you can see that they transform it into a different kind of game that's all their own. So that's another classroom that has taken the coding concepts, but students have remixed it and invented their own games with the supporting structure of the littleBits invention lessons in the CodeKit. And so after students, so at this point, your students will have gone through the Hello World lesson where they'll have been sort of brought into the community of coders and coded their first Hello World program. They'll have learned about the basics of coding concepts and actually explored them with bits. They'll have built 4 different game inventions and had the opportunity to remix them. And at this point, your students are probably feeling really comfortable with the basics of the block coding, which in and of itself as a coding language is much easier for students to read and understand because it is blocks of words that they can read and manipulate numbers and words within there. And then what's really exciting is you can now jump into like some really open-ended project-based learning. You can spend anywhere from 3 days on this challenge to weeks, depending on how far you and your students want to take it. And so it's now asking students, the final challenge, coding challenge, is an open-ended challenge, saying asking students to identify issues in their community. So their community could be their school, their classroom, the larger community. You can define community however you want. There are so many extensions and rich discussions you can have around this. And then they can work in groups or individually, or you can work as a class to invent games that will help solve a problem or help make something better or help teach their community about something. They use the littleBits invention cycle, which we'll get to in just a little bit. They get to really be creative and free play and free invent. And they collaborate, and they're building on those skills that they learned through the coding tutorials and through the inventions. This video I'd like to show you isn't directly using CodeKit, but it is a student using littleBits to solve a real-world problem. And I think that's what's most important about this coding challenge and where we're taking you by the end of this unit on coding is that really helping students bring it into a real world context makes it a lot more meaningful. So I'd like to show you this student video now.
Hi, I'm Max, and this is my littleBits powered invention, Social Cat. There is a big problem in today's world. Each year, 1.5 million cats are euthanized. One of the main reasons is because they're not properly socialized or used to humans. That's a problem because they can't be adopted. I really wanted to help with this problem, so it got me thinking, what do all cats, or animals for that matter, love? They love to eat. So I thought, what if I could combine the pleasant experience of eating with the human voice? I spoke with director of OAR, Ohio Alley Cat Resource, Devin Smith, and she said that my invention was scientifically sound and she knew of no other inventions. So I searched Google, Amazon, PetSmart, and found no other inventions like this, so I got to work, and I knew I could do it with littleBits.
Go.
When a cat would come up to Social Cat, the motion trigger would activate, sending an on signal to the MP3 player, playing a voice and piano file. But here, have some treats. Come here. We just want to love you.
So I'm going to pause it there, although it's adorable and you can watch this on YouTube. But what's really incredible here is that you can see that when students are allowed to pick something that they're passionate about and given the tools to invent something, to act on something that they see as a problem or a challenge, their learning is so much deeper and so much richer. I mean, the way he spoke about how the bits work, the way you heard him connecting with outside resources and outside community organizations and researching things on the internet, it really becomes real-world project-based learning where it's beyond the codes and beyond the bits. This becomes like a fully a super well-rounded project where students are really doing everything from research to community outreach to invention. So, I mean, this is just an amazing example of why it's so important to always bring it back to the real world connection. So, assessment. How are you as a teacher? How are you understanding that your students are learning about the different coding concepts? Where can you identify where they might need extra support or might need extra review? What does the littleBits Code Kit have built to help you with that? So all littleBits are built, kits and bits are built around, and experiences are built around the invention cycle. And it's this cycle, and it's a mindset that we really want to teach all youth, because we feel that this type of mindset and way of thinking is necessary for to make them future ready for the careers of the future. And so the littleBits invention cycle takes them through a cycle that they can use endlessly in different contexts as they grow and in different parts of their life. So they learn always to create. They usually start somewhere around the creation part, and then they play with their invention. And through play, they learn what's working, what's not working. They have the opportunity to think about things they might want to change or improve. They remix, so they can remix to fix something, they can remix to make something better, or they can remix to make something into a totally different invention, or serve a totally different purpose. And then they share, and that's where we're really bringing in the real world, having them share with audiences outside the classroom, outside of their home, showing the real world context, and getting feedback, so that they're not just doing an assignment for their classroom or their teacher, but they're doing something that they feel is actually meaningful in the world. And so there are materials that are provided in the hub that you can print out and give to your students to walk them through that invention cycle, and make sure that they're documenting their thinking, so that you can then look at that documentation to assess their learning. So as they're going through the coding tutorials, there is a Codemaster workbook, and you see the first page of it here. Again, you can modify this, but students are prototyping on here. When they're learning about inputs and outputs, the first prompt is for them to draw an output and input they use in their daily life. So again, it always starts with where they are, what they know in their daily life, and then takes them to the coding. And so this workbook is available to accompany the app for you and your students as they go through those beginning lessons. And then as they move into the inventions, there is an invention log. And this, again, takes students through the invention cycle with creating, playing, remixing, and sharing, and has different prompts and questions and challenges for students. They prototype their code. They can sort of come up with new ideas or better ideas and troubleshoot here. And then in terms of students providing feedback for one another, which is really important to have in the classroom, that students are doing self-assessment and self-assessing one another's work, sort of giving feedback and opinions and advice. There's a feedback chart that's created for you where students very simply just give a glow, a grow, a question, an idea when their peers are presenting their invention. So the glow is like what's really awesome, what's working well. The grow is, sort of pushing them, or a challenge to do something a little better. A question is just that. An idea is something new that they want to suggest to that group or that inventor. And so those are the Code Kit resources. So you can see you have everything from the video tutorials to student handouts, teacher lesson plans. I didn't show you the teacher lesson plans, but again, I did show you, and I highly recommend that you go to the Code Kit hub, the Code Kit educator portal, and you can download those lesson plans and you can take a look at how they're laid out. You can download the app, which is free. So again, I highly recommend this, because before you have to invest or think about investing a single dollar in the kit, you can see the app for itself, which I think will really amaze you when you see how great these student-facing video tutorials are. So before we go into questions and answers, so I'll be looking through whatever questions you've put in the chat. I just want to let you all know that this was our second webinar on teaching coding in a series of 3. Our next one will be on December 6th at 4 p.m. You can register at the URL that's highlighted at the bottom of this screen. And we're going to dive deeper into engineering and coding. So for those of you who might have students who have experience with Scratch, have experience with block coding, you may be thinking, okay, well, this is really just for very, very novice beginner coders. But there's actually a way to have experienced coders use the code kit to very meaningfully invent and progress with their coding skills. So join us on the 6th, register today. And again, if you register and you can't make it, even if you know you can't make it because of the date or the time in your time zone, it's still worth it to register. It means that we'll follow up with you and give you a recording, access to a recording. And so now we're going to move into questions. If I don't get to your question, please feel free, or if you have to go at this point, please feel free to email your questions to education@littlebits.com. And we'll be happy to make sure that that gets to the right person, if it's not myself, to give you an answer. So for a question and answer, I'm going to just bear with me a moment so I can get to your questions. So my camera's going to go off for this portion, but you all got to see, see me during the presentation. So, you know what I look like, and I'm really here. And so you can continue to put questions in this question section. Bear with me as I review them, and then I will address the ones that I can out loud. And then again, if you have questions related to purchase or product, Max, my colleague, is on the back end, and he can directly reply to your purchase, sales or product questions in the chat. Oops, we're not on thank you. We're still on questions right now. So just bear with me while I take a look at some of your questions. So I'm just looking through your introductions, and so one of the things that I realized might be useful is that the code kit is recommended for grades 3 through 8. But that's a wide range, as you know, and so it's really dependent on how much exposure your students have had to coding and computer science. So it's as applicable to an 8th grader who's really coming in as a novice as it could be to a 3rd grader. Within that band, the app is really aligned to standards within those grade levels as well. See a lot of, we have some people from all over. We have people from all over the world joining. This is super exciting. So a lot of you, are either librarians or tech coaches. A lot of elementary and middle school. Wonderful. I'm trying to get to your questions. You guys were all really good at introducing yourselves to one another. Okay, so some people were asking about how they were interested in just how do you do an introductory unit, which I hope that I walked you through today. Get beyond the basics. So yeah, I think there are a lot of resources. Someone wrote that they have a littleBits kit and they want to go beyond the basics. And so I really would point everyone to, if it's code kit, to utilizing the resources on the app. And if it's not, you can, through visiting littlebits.com, you can link to education at littlebits.com. Which is the littleBits Learning Lab, which is full of learning content that you can use, and inspirational content that you can use to go beyond the basics. And if some of you want to put in, will the app work on the Chromebook? So yes, the app will work on a Chromebook. The app is currently supported on Macs and PCs. Let's see. So for product questions about specific bit functions, those would be best if you emailed education@littlebits.com, and we can get that over to someone on the product team. And someone asking about grade level, yes, middle school would be great. So there's a question, can you switch to text-based coding? So at the moment, you can't. It's just the block-based coding within the littleBits app. However, this is something that many teachers have asked us about, and it's very much on our radar, and it has been brought to our product development team. So stay tuned because we do have that in mind. For anyone who wanted a link to the Hello World recorded webinar, I'll go back at the end of this to that slide where you can register for the replay yourself. Okay, wonderful. People really liked Social Cat. The cost of the kit, hopefully my colleague Max got back to you on this. Pricing questions. You can rewatch this webinar, so we'll follow up with you since you registered. Everyone will get a email with a link to watch the replay. So anyone who wanted to go over something or see something can do that. And yes, again, to clarify, the assessments and most of the handouts are downloadable in a Google Doc format so that teachers can modify for student populations, for sure. So a question about the invention cycle, could I explain about the GLOW? So the GLOW is actually not part of the invention cycle. It was part of the peer feedback chart. And it's just a way to have students give feedback in a well-rounded way so that they are giving positive feedback as well as constructive criticism. So the GLOW is really an opportunity for students to compliment their peers on something they did in their work. And the name of the app is the littleBits Code Kit app. You can access it by going to littlebits.com, clicking on the Code Kit product, and then you'll be able to download the app. So here's a teacher writing in about having only 3 Code Kit sets and 26 students. And so what I suggest is if you are unable to have the 3-to-1 ratio for students to all be working on the Code Kit, doing station work or incorporating Code Kit as a station within a unit on computer science or sort of STEAM-based station work is a great way to have students rotate through. And so it could be that you have different types of work that students are doing at different stations, and Code Kit is one station, and then it just takes a little more time to have students cycle through, but there are lots of other resources that students can be doing at the other stations that will support you in teaching, introducing them to coding. So someone asked about interplay between the kits. So the great thing about the bits in the Code Kit and littleBits in general is that they're all compatible. And so if you have, for example, the Gizmos and Gadgets kit or the STEAM student set, and you get the Code Kit, all of those bits can be incorporated into the Code Kit to expand on the possibility of what your students can invent. And someone is asking the website for the more advanced classes. I'll scroll back to where you can register for our next webinar, which is about how to take students who already have the basics of coding into a deeper experience with the Code Kit. The app is free. We got a couple of questions about that. And that looks like I've gotten to the end of your question list. I apologize if I missed it, so please email at education@littlebits.com if you did not get your question addressed. I'm going to now scroll back to some of those slides you asked for. So if you want to register either for the upcoming webinar on taking a deeper dive into coding, please visit the URL at the bottom of this screen where you can register for our next webinar. You can also go there to request a replay of our first webinar, which was on teaching an introductory lesson in coding, the Hello World lesson. And so that is available for you at that site. I'm going to go back to the educator portal because many of you, or a few of you, had asked about taking a closer look at these resources and the app, which I highly recommend. So if you, let me go back a little further. So if you visit the URL that is highlighted at the bottom of this slide, you will see here the opportunity for you to download the app directly from here, access all of the lesson plans that I talked about today, download the handouts, modify them, view all of the videos, and then once you download the app, you can view all of the content within there. So you can do that by following the URL here. You can also go to littlebits.com, and if you click on teachers and then click on CodeKit, you'll be able to get to this page of CodeKit educator resources as well. Okay, if anyone has any final questions or comments that they wanted to add in right now, please feel free to do so. Otherwise, thank you so much for joining today. We know that you're all busy, and some of you that might be in the Northeast are joining despite the storm, so thank you so much. For those of you joining us from abroad, I know that the time may be less than convenient for you, so thank you again for your time. Thank you for all introducing yourselves, and we really hope to see you on the next webinar, which is going to be taking a look at how we can use the same code kit to take students into a more advanced study of coding. Just going to check for any more questions. Okay. Well, thank you all, and we wish everyone a wonderful evening, morning, and happy coding.